In this video, I will explain how iserver application can help you with OpenShift installation, data operations, as well as Fabric checks and configuration. You can access iserver in public GitHub. It is an open source tool. You can run it from Python sources. You can run it from single binary prepared for Linux and Windows operating system. You can also get the extensive documentation of the application in GitHub. You will need to define an intent, your input for cluster definition as well as for fabric definition. The cluster definition input files are used to interact with Red Hat's hybrid cloud console. It also defines how to access, upload, and download the files from the web server. Last but not least, defines which servers and how to control them will be used for OpenShift bare metal installation. The Fabric definition section is used to define either the checks or the configuration of the data center fabric to which OpenShift cluster nodes will connect. You need to meet the following requirements. First of all, you need to download the application itself from GitHub. You need to configure an application with OpenShift console pull secret and token, so iserver knows how to correctly communicate with Red Hat's hybrid cloud console. You also need to configure the Redfish credentials for servers interaction, inter-site open authentication in the context of server checks, firmware upgrades, etc. And also network controller credentials, so iserver application will know how to check or configure the network fabric. Your intent is defined in the set of files. The workflow can be decomposed to 4 major steps. The first step is verification. Verification of syntax, so all the input files data. Verification of authentication to Red Hat's cloud, to servers via Redfish, to network controllers or network devices. The access to web server for upload and download is checked, as well as the server's hardware inventory, firmware, hardware compatibility list via inter-site APIs. Once the verification step is completed, then the next optional step is for fabric checks or configuration. The next step is OpenShift bare metal cluster installation, followed with post-installation tasks. It is also possible to benefit from iserver application in the context of data operations by just having the kube configuration file for your Kubernetes cluster. iserver is a command line tool. So on the top, you see the example CLI options that will start the workflow for cluster installation. iserver, create OCP cluster bare metal. You always need to pass the directory name that has all the input files. And then you have the 2 options that control the mode of the installation of the cluster as well as the mode of the fabric checks or configuration. The table here outlines all the different combination of modes for a cluster itself as well as for the fabric, and you'll see which workflow sections will be executed based on the command options combination. If you want to delete the cluster, you can pretty much shut down the servers, delete cluster from the console.redhat.com, as well as unconfigure the network fabric. If you run a full installation of the cluster with or without fabric section, then you are on the left-hand side of this slide, where the post-installation tasks are executed straight after the installation. On the right-hand side of the slide, you have a different option to invoke iserver application in case where cluster was installed using iserver or was not installed using iserver. It does not matter because all the tool is expecting is the kubeconfig file. The workflow can do fabric check, fabric configuration. It can install OpenShift bare metal cluster as well as run post-installation tests. All the workflows implemented in iServer are meant to be without any user intervention. So all you need is your input data and you need to launch the command. It may take a while to complete, but it is designed to run to completion and it breaks on any error. Other videos in the playlist will explain different modes of operation and input files